The Foundations of Advanced AI, Explanation of Neural Networks. Welcome back, curious minds. Today, we're delving into the very core of advanced AI, neural networks. Think of these as the digital equivalent of the human brain's interconnected neurons, working together to process information. Let's break down this concept step by step. Building blocks of neural networks. At its essence, a neural network is a computational model composed of layers. Imagine these layers as interconnected nodes, or neurons, much like the synapses in our brain. Each neuron receives input, processes it, and passes it on to the next layer. 1. Input layer, the entry point where data is fed into the network. 2. Hidden layers, intermediary layers that process and transform data using mathematical functions. 3. Output layer, produces the final result or prediction. Activation functions. Just as our brain neurons fire in response to stimuli, neural network neurons activate using functions known as activation functions. These functions introduce nonlinearity, enabling the network to learn complex patterns. 1. Sigmoid, S-shaped curve, used in simpler networks. 2. ReLU, rectified linear activation, piecewise linear function, accelerates learning in deep networks. 3. HNH, hyperbolic tangent, similar to sigmoid but zero-centered, often used in hidden layers. 4. Feed-forward process. Now, let's explore how data moves through a neural network in the feed-forward process. 1. Input propagation. Data enters the input layer and is multiplied by weights. 2. Activation. The weighted sum passes through the activation function, producing an output. 3. Passing through layers. This process repeats for each hidden layer until reaching the output layer. 4. Final prediction. The output layer produces the network's prediction. Learning and backpropagation. Neural networks are not born smart, they learn through a process called backpropagation. 1. Loss calculation. The network's output is compared to the actual target, ground truth, and the error is calculated. 2. Gradient descent. The error is propagated backward, adjusting weights to minimize the error gradually. 3. Updating weights. Optimizers like stochastic gradient descent fine-tune the weights in the direction that reduces error. 4. Iterative learning. The process is repeated across many data samples until the network's predictions become accurate. Deep learning and beyond. The magic of neural networks shines when they go deep, literally. Deep learning involves stacking multiple layers to form deep neural networks. 1. Feature learning. Deeper layers learn complex features from simpler ones. 2. Convolutional neural networks, CNNs, specialized for image data, using convolutional layers. 3. Recurrent neural networks, RNNs, designed for sequential data, retaining memory of past inputs. 4. Long short-term memory, LSTM, and gated recurrent units, GRUs, variants of RNNs for better handling long sequences. Congratulations! You've just scratched the surface of the powerful realm of neural networks. In the next episode, we'll explore even more advanced AI concepts. Until then, keep those neurons firing with curiosity.